In my last episode, I talked about calculating pi with only armor stands and placing them in a circle. In this episode, I'm now going to talk about the square root algorithm I used to calculate the distance between the armor stands. Calculating the square root with operators like plus and multiplication is fairly simple. First, we need these three variables: the input, some counter, and a variable where the result is stored in. Now, here's the algorithm. First, we initialize count to the value 1 and set the input, for example, to 16. Now, unless count times count is bigger than input, we just increase count. Okay, to make this more clear, a simple example for 16. We start with the count value of 1. We multiply 1 by 1. This is still smaller than 16, so we increase count by 1. Now we are at count 2. We now multiply 2 by 2 again, like here is shown in the algorithm. We get 4. 4 is still smaller than 16. So we increase count by 1. Now we have count 3. 3 times 3 smaller than 16. Increase count again. Now we have count 4. 4 times 4 is no longer smaller than 16. And now we break the while condition and come to the point where we set the result. This algorithm is fairly simple, but also it is very slow. For example, if you have a very big input and the time it would take to calculate this input is the square of the input. So square 10,000 would take 100 iterations. It's still very fast, but it can be even faster. And for that, surely one thing I forgot to mention, this algorithm always gives out a rounded result. So if the input is 20, there are no comma values in Minecraft. So for 20, the result is 5 and not something like 4.3, something like that. Because 4 times 4 is 16, is still smaller than 20, and only 5 times 5 fulfills this condition to break the while loop and sets the result to 5. Okay, now to the faster algorithm. The idea here is to not increase count by 1, but to double it each time we reached our limit, our condition. Okay, I'm not sure how good I can explain this algorithm, but we need one more variable, long count. And here at the top, we just simply add both counts together and multiply them. We still start with count of 1. And now we have 3 or 2 if conditions down here. The first if condition is the one that would also finish the program. And it basically says, okay, we have count plus long count, the same condition as above here, times count plus long count. And if this is bigger or equals than the input, and the count is set to 1, we have found our result. Okay, why is there this 1 here? This 1 here means that down here, this part has been triggered the last time this has been 1. And this means that everything bigger than 1 added to this equation here always keeps overhitting the input. So 1 is the smallest number that still can be added to meet the input requirement. And if then all these conditions no longer, and if all these conditions fail, we just have down here our basic condition that count is multiplied by 2. Okay, just a fast showcase in Minecraft. I will just skip over to command blocks. This command block here detects if the result was set and deletes the redstone block here. Sets the redstone block somewhere else to trigger another contraption for the other thing there, but not relevant for here. Now here, count total. That's representative for the if condition. And here we just set it to count, and then we add the long count. And before here we have no conditions, so just a player's operation. Here we execute only if the result was not set, but that's only the thing because I want to stop it if the result was found. And here we are computing the count total square. So C2 is set equals to count total and then multiplied times count total again. And here we have our first breaking condition. This condition checks if the algorithm is finished and has found its result. Checking here for the normal count checks one condition, and if so, setting the result to the count total. And in here we check the other condition if the count is bigger than the input, or the count squared, but the result wasn't set yet. We divide count by 2, and then later we add count to long count. Then we set count to 1 and multiply count by 2. That's the else case in the program if this condition is met. And then everything starts from the same again and again and again and again and again to calculate the square root as fast as possible. I hope this helped. I hope you enjoyed it, and bye.